Okay, today we're going to be installing a Stratus. First thing we always want to do is make sure the site's clean and go through our information that we have in the yellow envelope. As with Crystal, that's all the information that we need to position our elevator in the shaft correctly, to wire it correctly. We've got the manual that has the installation instructions and some service information. Warranty information is in your yellow envelope. Your packing list to make sure that all the parts that were supposed to be there were delivered. Also, various drawings just showing how the car goes together in case you need additional information for that. So that's all in the yellow envelope. And one of the first things that we want to take out is we're going to get the installation drawing. On this drawing, it shows the size of the car and the position of the doorways. So we're going to just double check out our shaft, make sure that we have enough space to install our elevator. So today what we have here is a 40 by 54 car that we're going to be putting in here. And we have our dimensions on page 2 of the installation drawings that show the shaft dimensions, and also we'll refer to it later when we're positioning the tower, because the tower position dimensions are in here as well. So important document that we want to keep with us while we're doing the installation. So we'll go over here and check our shaft, make sure we've got the right size. Okay, so we're ready to measure our shaft. And what we're going to do, again, we're going to go to page 2 of 6 of the installation drawings. It's a plan view of the shaft measurements. And we're going to measure the shaft depth, which we referred to from the distance parallel to the tower wall. So, and that is the tower wall. So we're just going to take measurement there to see what our actual shaft measurement is. And we're 59 5/8. And that dimension is 1/8 of an inch bigger than the design dimension, which is okay. And then I'm going to measure a couple of different places along the length of the shaft to make sure that I'm within 1/4 to 1/8 of an inch of that shaft depth dimension. The second dimension that we want to measure is the shaft width, and that's the distance parallel to the tower wall, so from this side to over here. And we're looking for a dimension of 54 1/2 inches for this size of car. And we've got 54 3/4 inches. And again, I'm going to be measuring at the bottom, the top, back wall, front wall, and I want to be within 1/4 of an inch, hopefully bigger than smaller than the 54 1/2 design dimension. Another important dimension is the position of the door opening with respect to the tower wall. So every drawing has a dimension showing what we call the door return, which is the distance from the tower wall, finished tower wall, to the rough opening of the door. So in this case, what we're looking for is 9 inches on the first landing. And we are bang on 9 inches on the first landing. Okay, another dimension that we want to make sure is right before we start doing our work is the door width and the door height. These are rough opening dimensions, but based on the door that was planned for this application, it will ensure that the opening of the door when the elevator is moving in the shaftway is lining up with the door opening. So it's important that the door sizing is matching the planned design size for this elevator. So we'll measure this width, and what we're looking for on the width is at the first landing is a 42-inch width. And we're 42 1/4 inches on the width. Hang on. And the other dimension that we're going to measure, and we'll get this one from page 4 of 6 in the elevation view, is the door height for the first landing. And on this one, it's 89 1/2 inches to the floor. As you can notice, There's no pit on this elevator either. And we're 89 and 5/8, perfect. A little bit bigger on the rough opening is not a problem. And 89 and 7/16, so well within the tolerances that we're looking for. Okay, we're up at the second landing, and another important dimension that we want to check is the overhead clearance, which is the distance from the top landing to the underside of the shaft. Now, this particular shaftway is open at the top, but most of our shafts that we go into are not open. So on this elevator, we need a minimum of 96 inches, and I'll explain why this one's a little bit different in a second here. But we've got 109 inches, so we have lots of clearance to the top of the shaft. And a typical Stratus requires an overhead clearance of 92 inches. In this application, it has the Q folding doors, which take extra height at the top level. So this one requires 96 inches, and we have that clearance here. Another measurement that we like to check before we proceed with the installation is the total travel. Now, the Stratus is quite simple. It comes in 3 tower heights. It comes in a maximum 9-foot travel, an 11-foot travel, and a 14-foot travel. So what we want to check just to make sure is that the travel of the building from the bottom floor to the top floor is at least less than the unit that we're going to be installing. So the unit that we have here is an 11-foot travel, maximum travel unit, and we're going to just check the floor to floor from the pit. And of course, if you do have a pit, which we don't on this one, but it's important that you always measure to the bottom of the pit because that's where your tower sits. So we're coming up to the very finished floor. It's just over about 129 1/4, and this unit can travel up to 11 feet, which is 132 inches, so we're good. We prepared our workspace with what we call our work scaffolding. We prepare this at every landing that we're working at above the lowest landing, of course. And very simply, we take 2x4s and we put them about fairly close together, 1/4 inch apart, and put a couple screws in at this side here to keep them in at that level. This particular application has a through door, so it's kind of convenient. We can put the scaffolding on both edges, and they're supported well. If we only had one side access, we might put a ledger plate over here on the wall, and we would support this end on the ledger plate. But you have the 2x4s going across. You want to keep a bit of distance between the tower wall, so we have about 15 inches between the tower wall and the first 2x4 here. And you can run this side, as close as you want. But we like to be, on this side, we like to stay under 12 inches just to maintain a safe working space. We also cut a few small 2x4s and put them underneath 2 runs, one evenly spaced, one here and one here. And that just keeps the whole platform rigid so that when 2 people are on here working, you've got a rigid workspace that you can easily work from. So we're set up and we're ready to install the Stratus, and we've positioned the tower over in front of the shaftway there. It's the first thing that's going to be going in. The rest of the components here, this is pretty well everything else you may see in your Stratus package. And you'll see we have the electrical tech cables with the call stations and the door locks. We have our parts box right here that has all the fasteners. It's got the COP, some shims, and all the small parts that you need to install your Stratus. This is your electrical controller. That has all of the main power drive for the motor. It's got a UPS in there to provide battery backup for the car lights and the alarm, and some breakers and whatnot in there. These are brackets that we use to mount our controller. We'll be dealing with those later. Over here we have the the car platform. So we position all of these things in the order that they're going to be installed once we do them. So the car platform is sitting here. Behind the car platform, you'll see the quick cab panel. So the one in the very back is the ceiling, and the ones on the front, the tubes on the side are the walls that we're going to be assembling the car later on. And over here is our car Q-fold gate. So this unit has a front and a back Q-fold gate, and they're sitting there ready to go. So these are all the parts that we're going to be using, and they're positioned in a way that we can grab them as in the order that they're going to be installed. Okay, so we've moved the Stratus tower assembly into place, and you can see it comes as one unit for the 9-foot and the 11-foot travel towers. The 14-foot tower, when you receive it, will actually be split in two pieces because it's too big to go in one crate. But this is essentially what it will look like when it comes out of the crate. And I like to use a couple of dollies with universal wheels on both ends so that you can easily move the tower into place on a construction site without carrying it the whole way. So it's at the moment it was brought into position on the two dollies lifted off of the crate, and we're ready to start installing it. Okay, so what we're going to do in this application is we're going to split the tower. 90% of the time, the tower will not fit into the building in one piece, so the Stratus tower can be split at the upper section, which is always the same length. The lower section changes in length depending on the travel of unit, but there's 4 bolts here that connect the upper section to the lower section. The screw has a simple pin joint that will just separate when we go to split the tower. And all of the other heavier components are located up at the top of the tower. We have the motor, we have the manual crank, we have the brake and the drive system. So by splitting it, we can handle these components individual or as one smaller unit and easy to work with. So we're just going to go over some of the components, the main drive components on the Stratus. And at the top here we have it's a 1.5 horsepower 3-phase motor. It bolts into the top tower frame. It drives a synchronized geared belt that turns the bigger gear on the screw underneath here. The motor is controlled by a variable speed drive in the controller, so it has a soft start, soft stop. This switch here is designed to sense that if the belt ever gets removed or breaks, it will shut off power to the motor and engage the brake, which sits right on top of this plate right here. The other component that we have on the top of the tower is the 90-degree manual crank. It's unique to the Ram Stratus and also used on the trusty lift, but it will be accessed from the outside of the shaft, and it only engages when it's pushed in against the spring, engages with the upper gear, and then it can be rotated right or left to raise or lower the car in the case of an emergency. You can see the spring there. There's also a switch here that shuts the power off to the motor as soon as you engage the crank. The next component is the drive screw, and I want to point out here that the drive screw, you can see it has quite a steep angle to the threads. It's a 4-start screw, so it's a 1-inch diameter 4-start screw. So every time it rotates, it moves roughly 0.8 inches. It's pinned right into the coupler here, so when we go to separate the tower, this pin cotter key will come out, the screw will drop down, and it makes it easier to separate and take the screw out and put it in after. Okay, the next component we have in the tower is what we call the screw stabilizer. Now this stabilizer is sitting just roughly loose here, but it floats up and down with the guide frame and literally keeps the screw vibration to a minimum. As you can see, it's got plastic UHMW guides. It's got a nylon bushing that goes around the screw, and then as the car comes up, it'll pick it up, and then it'll move up with the screw when it goes to the top of the travel, and then come back down when it comes to the bottom. So the stabilizer is very important. We set the stabilizer in the factory, so when we go to split it, we're going to try to keep the settings the way they were set in the factory, so we don't have to reset the stabilizer, which is another maintenance or procedure that can be done. But during the install, if we don't have to, we'd like to maintain the setting from the factory of the stabilizer. The next component on the tower is what we call the carriage guide frame. It's basically the frame that will move up and down on the screw when the screw rotates, and the drive nuts will lift the carriage guide frame, which the carriage floor and all the other carriage components attached to the guide frame. So on the guide frame, we have what we call our PC board controller. Also on the guide frame is what we have is we have position sensors, which we call the encoder. Those point back here, and they will see a magnet along the length of the tower. There's a little magnet just stuck right here right now from the shop, but every time it goes past a magnet, it's counting four pulses so that it knows that it's in between floors or above a certain floor or below a certain floor. On the other side of the guide frame, we have the lower and upper terminal sensors. Again, they're magnetic read sensors, and they sense the bottom position and the top position. The bottom one sees the magnet at the bottom travel. The top one sees a magnet at the top end to travel. We also have just a mechanical positive brake switch called the upper final limit, and that one is a safety switch that will stop the car in the up direction should the upper terminal switch fail. Another group of switches that we have here we call the door read switches. So at each floor we have again, it's a magnetic read switch that'll see a magnet when it's the lower one is for the lower door, the upper one's for the upper door. When it sees the magnet, it will close the contact and send power to the door lock to unlock the door. And one of the last components on the guide frame is the drive nuts, which are located at the bottom of the guide frame. There's an upper drive nut, which is what we call the main drive nut. It carries all the load. And there's a drive nut that sits right below it, which we call the backup drive nut. The backup drive nut actually never carries a load unless the main drive nut fails. And when that happens, it'll fall down onto the backup drive nut. It'll activate this the lower final limit switch and stop the unit from running until the main drive nut is repaired. Okay, another thing I wanted to point out, it's important when handling the Stratus tower before it gets installed, is supporting the screw. And you'll notice when you get the Stratus shipped, it'll have a couple of styrofoam blocks that's supporting the screw in a few different places, maybe 2 or 3 depending on the length of screw. These blocks are important to stay in place until the tower is either standing up or the screw has been removed and standing up in the shaft, which is what we're going to be doing with this one. If you receive a crate, uncrate it, put it on a trailer, and drive a number of miles without the screw blocks in place, the weight, just the weight of the screw on the road will cause the screw to bend, and you'll have a vibrating screw once the machine gets running, and we want it to be as smooth as possible. So we're getting ready to split the tower. And in doing so, what we want to do is break the tower up into easily manageable pieces. And one of the first components that needs to come out is the guide frame. And to take the guide frame out, we have the 2 pins, which is the back sliders. We have the reed sensor brackets that have to come out as they will catch when it comes out, the drive nut bolts, and also a stop on the back side of the guide plate at the bottom. So first thing we'll do is we'll take out the sliders, and they're The upper sliders come out quite easily. They're just pinned. Pins on the inside. Pull out the cotter key like so, and then pull out the pin from the other side. And it's out. Okay, on the other side, I'm going to remove the right slider. Take this one out. And the sensor bracket also needs to come off. 3/8 wrench and a square head Robertson or a flathead screwdriver. There we go. They're loose. So what I like to do with these as well is just, we don't want to bang around these little magnetic reed sensors, so I'll just fold it back up over here so it's, when we're carrying it, we're not going to damage it. Okay, next part we're going to take off, it makes it easier to get at the drive nuts after, is the stabilizer connecting rods. And those are just easy to come off because what they'll do is they just separate the distance between the two stabilizer plates, and there's really no settings involved with these parts. So by taking them off, it's actually it's an easy component to put back on after. So we're going to take the angles right off. Take off the upper one as well. So one thing I like to do, just makes the installation go easier, as I take some of the longer sections out, I'll go stand these up in the shaftway on the corresponding side that I took it off from, so we don't have to figure out which end is up and down and or right or left. So we'll go put this into the shaftway. Another stopper that we need to take out is, it's just referred to as a safety stop on the carriage guide frame. There's one on the front side, which you can see right here, and there's another one on the back side, which is right down here. Basically prevents the car from pulling out off the slider should the platform ever get caught on anything in the shaft. So we're going to take these two little stoppers out here as well. There's one on the right and one on the left side. We've removed the upper sliders, the upper switches, the back guide frame stops, and now we're just going to take out the bolts on the drive nuts so that the whole guide frame would literally just pull right out and separate from the tower. So 1/2 inch socket and wrench on the other side. You'll notice that there's springs here, so you have to be a little careful as you get towards the end of them, but when we go to put them back in, we'll literally just put a similar amount of tension that you see there right now. It's not a very critical item on Stratus, because it just needs to be some tension to keep the nuts from vibrating loose in the sockets. And we'll make a point of just remembering that the drive nuts are spaced roughly about 3/4 inch apart. So when we put it back together, we'll get that same spacing, and that's a code requirement as well. Okay, so the guide frame is now loose and ready to come off, but the one thing that we want to do is when we take the guide frame off, we want the travel cable to go with it. Now the travel cable is fixed to the top of the tower with this bracket, and we're going to be putting that back on when we put the tower and the guide frame all in place inside the shaft. And you want to make sure that the position is marked so that you can get it, you don't have to reset your cable length because it's already been set in the factory. And you'll notice this one has 2 travel cables, but they're all secured with tie straps. So as long as you keep this one marked and you keep the distance tight there, they should come back to the same position. So these are 7/16 bolt, and we'll just remove this bracket. So we've got the travel cable removed and it's off to the side. All of the bolts have been removed on the guide frame. It's ready to come out, but there's a couple more bolts that we should back off, and these are called the spring-loaded side sliders. There's one at the very bottom, and there's one at the top by the sensor bracket there. So they just need to be loosened up so that when we go to pull the guide frame out, the springs don't release. And so we'll probably back them off about maybe about 1/2 inch, something like that. Okay, so all the bolts have been removed from the guide frame. The side slider tension has been relaxed. Now we should be able to just pull it up, lift it up, and we'll stand it off, put it to the side until we're ready for it. There we go. Okay, well, we have the guide frame and the travel cable is removed. We're left now with the upper tower section and the lower tower section still bolted together, and the screw is still in place. And what we want to do is we want to take the screw out. It comes out easily now, and we're going to handle it carefully, stand it up in the shaft with 2 people so that it doesn't get damaged during the install. Again, it's the main drive component, and if it's handled carefully, you'll have a nice smooth machine when you turn it back on. But these are critical times where you want to make sure that you treat the screw with care so that you get a nice smooth machine in the end. So leaving the blocks in place at the moment, we have a pin at the top here. So we're going to take the upper pin out. There we go. There's our cotter pin. It's removed. So now what we're going to do is my partner and I will pull the screw back. It's going to come out of this section here down into the bottom, and we're going to pull just the upper coupler over to the side, and the screw should come up and out. We'll just pull her down there, Nick. And now we're out at the top, off to the side, and we're out at the bottom. We'll take the block off, and you can just run it off to the side there a little bit. There we go. Leave the stabilizer plates set and in place. The nuts will stay on the screw, and we're going to go stand this up in the shaftway. It's important to point out that once the screw is vertical, it's low risk of being bent. But it's when it's being handled horizontally that we need to be really careful. Okay, our screw has been removed, placed in the shaftway, and now we're ready to unbolt the upper section from the lower section. One thing that make it easy to work with is that we want to make sure the upper stabilizer slider that's all set in place in the factory, and we want to keep it that way, stays on the upper section. And so just an easy way to do that is just take a tie strap and run it through. There. Now, when we take the upper section, it's not going to fall down off the guide rails. So we have the upper stabilizer bracket tied up. Now what we want to do, before we split the large bolts on the tower, we want to just take off the 2 connecting bolts for the stabilizer guide angles. And keep in mind that the stabilizer positioning has been set in the factory as well, because these are slotted angles. So if you just take the big bolts out here, these are 7/16 bolts, it will keep the setting position, and so all we have to do is just bolt those 2 back together when we get it up in the shaft. So I'll take these apart right now. So last thing that we need to do is to remove the 4 1/2-inch National Course bolts that bolt the upper tower section to the lower tower section. And you'll see that the rails are lined up fairly nicely, but also the holes that are drilled through to make these 2 connections in the angles are drilled very closely. So when we put them back together, they should end up being very close, and we'll set them when we do it. But they're usually quite tight also, because we want this to be a nice connection. Our tower is split. Now we can carry the lower section in and stand it up, and you can see it's quite easy to manage now. And we'll just bring it in and walk it into the pit area. And we'll just move it up against the back wall. And it can just sit here loose for now, as we're going to put the upper section on after. Just down a little bit there. There we go. Okay. Got a winch to help us out. Okay. And I'll switch sides with you, Nick, and then I'll man the winch from this side. Okay, and we'll lift her up. There we go. A little bit of tension, and then we'll just don't have a lot of throw on this one, so we're just going to lift it up and
Over the edge.
and set it down over the edge. Just a second. Okay. Okay. There we go. Hanging on the winch. Very nice. Now we'll just let her down slowly. Just up on that ledge there a little bit, Nick. All right. So we have the upper tower section in place. We used our winch to lower it down, so it's safely lowered down onto the lower section. It's all just loose right now, but our winch is still secured to the top of the tower with a little bit of tension. And now we just need to line up the stabilizer guide angles and the tower angle connection bolts. My partner's at the top right now, just holding it in place, and he's going to help me to line it up from the top, and I'll work from the bottom. All right, let's get this one over, and there we go. Those are in place. I'll get these bolts in right now. So the bolt head on the inside, bolt head on the outside, nut on the inside, because you have the stabilizer guide shoe runs in here, so you want to make sure that this is brought in as far as it can go. Okay, so now we're going to light up the half-inch bolts on the main tower section frame. It's good to use a little clamp to pull these two edges together, because these bolts are pretty tough to line up. So I'll just put it right across the bracket here, and the bolts are fairly close tolerance. So what we're going to do is, a lot of times I'll get them started, and I'll even just put a wrench on there to try to thread them in there. It's a half-inch coarse bolt, so they're fairly durable. Put the nut on the bottom. Just get them all loose for now. We'll do a final tightening at the end. There we go. Tighten it up a little more. All right, so now we've got all of our bolts for the two tower section that connect them together. Just finger tight and loose, but now we want to line up the rail sections. And you can see that these bolts are loose, and there's a bit of pressure on them, yet the rails are pretty close. But what we're going to do again is we're going to use the clamp to come up against the face of the rail and and see if we can bring it in. And when I tighten these up, I'll just do it slow so that we don't throw off the joint connection there. We gotta make sure we keep it nice and straight. They're 1/2-inch coarse thread bolts, so when you get them close to being tight, as you can see when we took them off to split the tower, they were pretty tight, and we're gonna put a lot of tension on them this way too, basically as tight as we can get them. Our tower connecting bolts are tightened and our tower's lined up. Now we just want to line up the stabilizer guide angles, and the easiest way to do that is just use a pair of vice grips and just get on there and clamp the two together while you tighten that bolt. You'll have them lined up nicely. So we've now assembled our tower structure roughly in place in the shaft. We've tightened up our connections, and so the tower is sitting here. It's loose, but it's rigid. But what we want to do now is we want to set it in position, and we want to secure it to the wall. So in order to do that, I've pulled out of the box the 1/4-inch leg bolts that we're going to use to leg it into the wall, and shims that we'll use to shim out the tower in places where it's not matching, and also some steel shims for the bottom of the tower, because what we'll do is we're going to shim it either on the right or the left side to get the tower rails matching up with the wall. So we'll begin that now. When we're setting the tower rail position into the shaftway, we'll get out our drawing here, and we'll make reference to the dimensions from the surface of the rail to the shaftway, and that's shown on page 2 of your installation drawing. So this one shows 14 1/4 on both sides because it is a double entry car. So what we're going to do is we're going to be shooting for that dimension, but more importantly, we're going to be balancing it in the middle as close as we can as we go up. So what we want to do first is we're going to just push the tower back to the wall. So as we're doing all this, it's sitting nice and flat. I have a couple bars here that I'm going to use to do that if necessary. There we go. And I'm bringing it close to the wall as I can, but without putting any pressure on, because what we want to do is we want to get the tower sitting in the correct position, in a relaxed position, and then we'll secure it without where we want it to be once that's in place. So I'm going to measure down here and just see what we have. So I've got 13 5/8 on that side, and I got 15 over here. So it looks like I got to bring it to the left a bit, kind of thing. So now we're close here, and what we'll do is I got my partner up on the scaffolding at the top there, and what he's going to do is he's going to measure what he has at the top from the surface of the rail to the shaft there. So you want to check what you got up there, Nick? Okay, so we've measured the upper section, and we found that we're bigger over on the right side than we are the left side at the top. So we need to shim the left side of the tower to tilt it over to match the right side and the left side at the top, because at the moment it's tilting towards the left. So we're going to put a shim over on the left side to balance that out. So I'll have my partner use his mechanical advantage up there, and we'll put in a shim right underneath, and we'll put it right underneath the big 2-inch post. Okay, come on down. Okay, give her a little shake. There we go. And what do we got now?
14 1/2 on the right. 14 1/4 on the left.
Okay, that's closer. Right. So what we might do, so now it's a small difference now, but we're going to try. What I might do is I'll take a couple of other shims and I might just move it out closer to the angle so we can, because if I put another full 16-inch or 16-gauge shim, they're each 1/16 of an inch thick. That might move it a little bit too much. So what we'll do is I'll get you to lift it up again, Nick. All right. Okay. And I'll just go maybe just on the outside here a little bit to see if I can find the sweet spot. Okay, come back down. All right. Let's see how we did.
Just about 14 1/4.
Nice.
14 1/2 on the left.
Okay. We'll go with that, and so we're now within 1/4 inch, and we're also big. So being a little bit more clearance is better than running too small, because our design clearance is 14 1/4, and we're over that on all the sides. So we should be pretty good. And when we go to lag the top, we'll probably push it over even a little bit more just to get it closer to that center point. But that's looking pretty good. Our tower's now it's sitting relaxed in the balanced position. We'll do another check here just to make sure. And I always like to put the tape behind so you can measure on the flat spot. You can see that's just 14 5/16 and 14 and just under 1/4. So we're very close. So now I'm looking at my brackets. These two here are relaxed, and they're up against the wall. There's a couple that are pulling away. We'll shim those, and there's a couple at the bottom that are also tight. So I like to always get a couple anchors at the top, and then I'll go down and we'll do the other anchors at the bottom that are already tight to the wall, and then we'll shim the other ones before we put in anchors there. So you have your 1/4 inch by 2.5 inch lag bolt. It's important to note that all of the anchors below the top one can be put in with lag bolts, and we're not doing the top one for a reason right now. And then the top one is what gets the toggle insurance bolts that we'll do later. Okay, so we've anchored the top. The structure's now it's solid. As soon as you get an anchor in at the top, and notice we just did the second bracket from the top, as we said before, because the top one will get the locking toggle bolt. And now we'll come and put one of the brackets that's tight to the wall on the bottom. This bracket is tight here. I can see this one we'll probably have to shim, so we can drive this one in right away and get the bottom secured as well. Okay, so our tower is now in position. It's secured at all of the brackets that were touching the wall in the relaxed position. Any bracket that's got a space between the wall and the wall bracket, we want to make sure we shim before we tighten it up. Otherwise, it'll actually twist the welded frame, and you'll just get a little bit of potential sound when the car's running up and down under full load. So we'll just use these cedar shims, and see that one in there. You gotta remember it's gonna tighten up a bit. So what I'll probably do is I'll just cut this back a little bit here, so that I use a thicker part of the shim. Just break easily when you score them. There we go. So it's okay. It's okay for the cedar shim to be a little bit snug, because as we tighten the bracket, it's gonna pull it in a little bit anyway. So I'll make sure it's got nice and snug there, and I'll just take an anchor and drive that right through the cedar shim. And you just score the top of it and bust it off. There we go. We'll do that for the rest. Okay, so we've got the rest of the tower lagged in, and it's rigid, but what we want to do at the very top two bolts is what we want to put in is what we call our locking, our insurance bolt at the very top of the frame. We can use lags everywhere else in the structure, but the top two should be a locking bolt, and when it goes into the wall, it goes in straight like this, and then when you just pull it straight like so, straightens out the toggle, you pull it back, pull the little zip tie snap in to hold it in place, and then we'll put the screw through and lock it into the toggle. That way this is a solid locked in bolt behind the 2x6 that's in the C-channel shaped frame in the wall, and it will ensure that the structure is always stable no matter what lag may pull out in the future. So it's important that we get the locking toggle bolt in at the top. So in order to do it, we need to make a bigger hole. So we'll drill in a 1/2-inch hole through the top anchor, and that'll allow us enough room to put in the toggle. So I'll just straighten it out like this. I'm going to push it in, find that spot. There we go, I'm inside. Now I straighten out the two pieces so that they feel straight, and I pull it back so I can feel that it's locking up against the wall. Make sure I get this nice, and can't always see what's going on in there, so you got to look at the ends of the toggle to make sure you're getting it in nice and flat. Okay, that's the spot. Okay, now I can pulling it in, it's nice and flat. Now I'll pull this all the way up, and then these just break off like so. Like that. Throw that one out. Take my screw. Just a screwdriver. I like to put them in by hand because I don't want to strip out the nut on the back there. And then just nice, softly thread them in until you get into the metal nut at the back there, and then tighten her up. There we go. Okay, so our tower is secured. It's in place, and now we're ready to reassemble all the components that we've taken out of the tower, and we'll do it in the exact reverse way from the way we removed them. So the last thing we took out was the screw. The screw will be the first thing that goes back in. So I've got my partner stabilizing the screw at the bottom there, and I'll just take the tie strap off of here. We need to get the upper stabilizer in place first, so we'll just sort of put this in at a bit of an angle, and that, and just 1 second there, just get that. Yeah, so there's a bit of tension on the stabilizer, and now the screw can come up like so, and we'll get it into the bottom stabilizer. There we go. And now and again, just keep in mind that we don't want to bend the screw because we want to keep that straight, but this coupler can actually move out of the way, and that's how we do that. So I'll line this up there. I'll get my cotter pin ready. Okay, there we go. Good, nice catch. Okay, and we can just literally turn the screw by hand, and we'll put the cotter pin back in, and we'll lock it in place with the pair of needle nose pliers. Just turn it sideways, and it'll come over like so. The screw is in place and secured, and now we're ready to bring the guide frame in. I just like to get this upper stabilizer out of the way so it's not falling down on us when we're putting in the guide frame. So I'll just put a little tie strap around there, and it'll stay up there. Now we're going to go get the guide frame. So we've got our guide frame in position. Just note about the travel cable. You want to get it flowing in the right direction, so it comes down behind and makes a loop in the back corner there. You want to make sure you have it in position before we start moving it in. We're going to bring the guide frame in now, and want to make sure that the spring-loaded sliders, none of the sliders have fallen out in place. There's the top one, there's the bottom one. The other side are fixed. We checked that those are in place too. So as we bring it in, this is going to come in. The bottom slider is going to come up against there, and then we'll be able to put in the upper slider with the pin on the back, and the brackets and the drive nuts and everything else. So we'll just move it in slowly. I'll just give it a little nudge here. Actually, what I'll do is I'll bring in the spring slide first there, Nick. There we go, just because they have a bit of a, and then we can just, these will compress a little bit, and then you can get your side in usually. How are you doing there? There we go. We're in there. Oops. And we're in that one. And just lift it up. There we go. So now we're in place. And we're ready to put in the back sliders. Okay, we're going to put in the rear slider like that, and put the slider in place, line up with the hole, and then our key just locks the pin and the slider all in together. And there we go, locked in place. We're going to put in the back stop that we took out on the back side, similar to this one here, but it goes right in back on the back side here. That one's pretty simple. We just put it in, tighten it up. You don't want to tighten it up too much because it's just a nylon bushing, but give it a little tension, and that's good. Now we can put the reed sensor brackets back on in place, and just keep in mind that in case you forgot, they go on the outside of the guide frame bracket, and we have the small little number 10 by 3/4 inch screws that go from, I think I'd like to put them on from the inside and then put the nuts on the outside. There we go. We got our guide frame in place. We have the back sliders pinned in. We have the sensor brackets back on. One of the last things we need to put back on the guide frame is the drive nut bolts, the bolts that connect the drive nuts to the guide frame. So we've got our big washers here, and we have the small ones. Just one thing to keep in mind is that the big washers are the ones that always go next to the metal slots on the bracket. And so on the red one, I always do the bottom one first. So I put a big washer here, and then I put a small washer on the other side, like so. And then I like to get them ready, and I'll put another big washer here. Or another small washer, sorry, and then the big washer with the sharp edge. So now when I go to lift the nut up, I'll be able to put these two bolts through, and then the springs will come through on the other side. Okay, so I'm going to just thread the two nuts up so that they're easy to work on. I'll just get the upper nut we'll do second, and the lower nut is a little bit harder to access, so we'll bring that one up first. So now I've got my brackets ready, and it's actually kind of nice to work on the lower one when it's higher up in the bracket. So I'll just raise it up a little bit here and take these two, put one in there, and just sort of work it through. until it comes out the other side of the bracket. Okay, so we've got the lower bolts or the bolts into the lower nut and the red brackets in place with the washers on that side. We now want to get the springs and the washers on the other side, but a couple things that we need to do is that we want to move it down so we can then work at the upper one. Plus we want to set the distance between the two. So the distance that we want between those is about 3/4 of an inch. So every time this turns a half turn, we're moving 0.4 inches. So right there is about, we got just under 3/4. If we go a half a turn up, we're then 1 inch. And if we go a half a turn down, we're too close. So I think we're gonna go with this spot right here. It is approximately 11/16. So what I like to do also, now I want to move these both down together so I can work on the top one. So I'm going to have my partner use the manual crank to just turn the screw, and it'll bring the nuts down into the position where I can work on the next bolts and get ready to put the springs on. So want to bring her down there, Nick? As soon as I can see my holes, and I know I'm good. Okay, let's see how that works now. So now the upper ones just basically get the big washers with the sharp edge on the flat side. See if we can get this outside one in. There we go. That's that one. And we'll get the other one. So just keep in mind that the red bracket is always mounted to the bottom nut. And then we'll just pull this red bracket a bit back, get the limit switch into the center of the slot where it was before. And now what we're going to do is we're going to put the washers back on and the springs from the other side. But you can see it's a much nicer height to work on here, so that's why I like to do it like this. So again, we'll put all the big washers with the sharp edge on the inside. So I got all the big washers on, and then I have a spring, and then I have another small washer. And you got to be, it's a little tricky here on these because you have to sort of hold the bolt in place, push against the spring, and put a little, and to get the nut started there. So I'll do the same on this one. Now what we're going to do, we're going to tighten these up just to run the threaded nuts probably a bit past the end of the bolt there. There we go. The tension on these springs is it's not highly technical, but we want to make sure there's enough tension so that if the nuts, if they ever do want to slide down in the channels, which would mean that the regular sensor has failed, it'll hit the final limit switch and slow the screw down before it gets to the bottom of the slots. Okay, so now that we have our drive nut bolts in, we can put our stabilizer rods back in as well, because that's the last thing that goes on. And so we just, with partner up at the top here, we'll just run these and put this in there. And these are nice because there's really no setting to these. They just simply go on and get tightened up. We'll bring them up snug right now because the final tightening will be after we connect the lower section. Okay, we'll just take this now and let it go down to the bottom. There we go, and we'll come down and put it down in place down here. Good. We've got our guide frame in place, and now we're going to start running our electrical so we can get the car ready for moving. We want to put the travel cable back into the tower. Again, we'd marked a line at the bottom of the travel cable bracket where it goes, so we know that's where it needs to go. We'll just back off this, this bolt again here. And then we'll move the cable into there. Get it just loosely set, and then we can do a final adjustment on it here. Put it in with my fingers. There we go. Just tighten that up a little bit. There we go. There. That's the travel cable secured and tight. We've got our tower secured, guide frame, screw, everything's back in place. The cables are run over to the controller, strapped to the wall here, just left not terminated to the call stations for now because we don't have the doors in place, but we you can always just isolate all the wires and then connect black 3 and white 3, which is the door safety, which will allow our car to run when we're ready to go. So we want to put the carriage together. So we used the manual crank and we brought the guide frame up a couple of inches. We can see that it's it's been raised probably about maybe 1.5 inches off the ground, something like that. It's a good height. We've carried the platform into the shaft. We've centered it. It's lined up, and we just put a belt through on just around the middle and to center the weight. We have our winch set up. So we're going to try to use the winch to help us position the platform. We've done this manually before, but using a tool is a little bit nicer if you can. It makes it a little bit easier. These two bolts here basically connect the carriage platform through these holes on the guide frame. And you can see on the back side of those bolts is a steel lock nut. So I'm going to take these bolts out. They're installed during shipping, but they are into a steel lock nut, so they're designed to be difficult to come out. Okay, we're ready to lift the platform up. So just give us a bit of lift there, Nick. About 6 inches. There we go. Just keep going. Yeah. Okay. That's good. A little bit higher, please. Oh, okay. There we go. Okay, let us down now. There we go. Keep coming. Yep. Keep coming. All right. Well, hang on. There we go. And I'll just keep moving her in here. We can use the strap to pull up from the center. Okay. Whoa. 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 Looking nice. Just a second. Can you come back down a little bit? That one's in. Just give it a little tightening there. Just remember that these are pivot bolts. They're actually they're designed to go into the steel lock nut, stay tight, but not rotate out. But we don't actually tighten them here because we have the tilt bolt right down here. That'll be adjusted to adjust the tilt of the platform. So the pivot bolts support the car. The tilt bolts adjust the leveling of the platform. So we'll bring it in a little bit more so it's secure. Okay, so got both of our bolts in. You can see this one here, they're both tight. You can see there's a bit of thread on this side, and we're well threaded past the steel lock nut on this side. It's basically acting as a pivot, and we don't want to clamp this plate. We want it to remain loose so the car can pivot about it. Our platform's in place. The pivot bolts are secure. And now what we want to do is we want to level and balance the tilt of the platform. Really important step here because this is going to provide a stable and solid car ride for the future of the elevator. So you can see this one right now is that it's kind of rocking back and forth, and it's actually the tilt bolt on the right hand side is hitting, but the tilt bolt on the left is bouncing. So there's two things I want to do. I want to have a balanced tilt or leveling bolts. I use language on both of those. And I want to be level, but over level, probably by 1/8 to 3/16 of an inch. And we're going to go as much as 3/16 on this unit because we have two auto gates being put onto it. So they're a bit heavier, so we want to compensate for that. We're probably coming up a little bit too high on this one. So what I'm going to do is I'm going to back off this tilt bolt and extend this one till I get them nice and level. So this one is going to, I'm going to actually bring it in so that the car comes in this way. So I'm actually going to thread it into the thread. Okay. I'm getting a little closer to where we want it now. I'm just up less than 1/8 of an inch. So across the whole distance, we're probably closer to 3/16. Feels pretty solid, but I think I can feel it coming off of this side just a little bit, and yet my tilt is pretty close to be where I want it right now. And you can also feel the just the tension on the bolt itself. When I went over to this side here, I could feel that it's a bit looser than this side. So now I'm going to go back on this one here. Yeah, you feel that one. And you know, when you're checking the tension, it's just about how it feels. We're still tilting up nicely. I'll pull this one in just a little bit more. There we go. Taking a bit of time to balance these bolts is time well spent, because you can see right away that now whatever little bounce was happening in the car before, or right or left, is actually gone. So that's feeling pretty good. I can see still up over here, even when I put all my weight on this side, just still a bit up over level. So that's a nice solid car. Really important step to making sure that when you get all the weight on your car, your doors and everything operate nice, and it's landing level with your landing. So that's the platform leveling. We've leveled our platform. It's nice and solid. We got both the tilt bolts balanced really well. When we put the guide frame in, or when we took it out, I should say, we backed off the side slider tension spring so that we could get it out. And we didn't actually tighten it up again until we actually have the platform suspended. So there's this bolt here. You can see it's loose right now. And then once it goes against the spring, I'm going to put some tension on it, and so that it keeps the car and pushed up against the left rail. So we'll just get our socket on that, and this can be adjusted again, but now is a good time to put a little bit of tension on it before we start putting weight on the car. So I have one at the top and I have one at the bottom. That one's a little harder to get at, but we'll put some tension on that one as well. Okay, so our platform's installed, the tilt bolts are set, the level is set nice. We're a couple inches off the floor. We like to be a little bit suspended. And now we're ready to assemble the quick cab. So there's a couple components to the quick cab. The first ones are the carriage support tubes. That's the only metal other than the panels that go into creating the quick cab structure. So they're usually labeled right front RF there, left front LF over here, and there's two bolts that they bolt to the platform. They bolt to this slotted bar up here, and they bolt to another slotted bar down there. And the nice thing about the slots and these bolts is that it allows you to adjust the tilt of your cab. So if you decide you want to tilt it up a little bit more, you've got adjustment in these slots where you can bring the tilt of the cab forward or back. So this one has been set up in the factory, and so we're gonna match it with the face of this tube is going to match with the inside face of the channel where the panel is going to be going in, and that should put us pretty close to where we want to be. So we'll take these bolts out. All right, just get the top one in here. Finger tight for now, and we'll get the bottom one in. So we just snugged this up, but it's just flush with the inside of this channel, because when the quick cab panel goes in, it's going to get tightened up against this tube, and it'll also get tightened into the channel as there. So we don't want it pulling forward, and we don't want it too far back. So we'll just give it a little bit of a snug there, like so. And then we'll tighten up the upper one here too. And then what we'll do with the upper one for now, again, there's slots here, but we'll just see if we can make it level. So we're level there. And that's going to help set our car position as well. So again, we don't want to over tighten any of the bolts that are going through a tube. It's a 1/8 wall tube, so it's quite sturdy, but with any of these bolts, you can over tighten the tube and actually just collapse it a little bit, and we don't need to do that. So the nylon lock nuts on the back, good snug connection is all we need. So that's the right one. All right, so we're ready to install the quick cab. We've got our structural supports, the right and the left quick cab tubes in place. Those are all tightened up and leveled. Now we're ready to put the cab together. And interesting thing about the quick cab is that there's no two separate structures. You don't build the structure and then put the panels on. The panels and the structure are one and the same. So the quick cab, living up to its name, actually goes together fairly quickly. What you need to do is, you'll see the whole cab's been assembled in the shop, so all the panels will match number 3D. We'll go to 3D, and then 4D is in the center, so we'll see that one match up in the center. But you literally just match up the numbers with the tags, and the last part that goes on is the ceiling, and it ties it all together. So we're ready to go. Okay, up, and there we go. Tapes are matching up. You can just hold that, and you'll notice too that all the screws that we're putting in, we're going to put in loose right now. The channels are designed such that when we do tighten up the quick cab at the end, it'll actually clamp the panels into the channels, making it rigid. So right now we just want them to all be loose in place. And all of the screws that go in here they're a button head stainless screw, so they're specific screw for the inside of the cab, so they look good. Okay, so we're ready to lift up the ceiling in place, and again, ceiling is going to go up and it's going to tie into the upper section on this side and these two panels over here. We've left this side open. This is actually the service panel side, and you'll see that this is left open intentionally because this panel is the one that gets removed every time that we service the elevator. The rest of the ones will be fixed. So when we bring the car top up, they're going to tie into the two structural support tubes. So we're going to take these two screws out right now so that we're not struggling with them once we get the car up there. So now we're ready to go there. So we'll just, I think we can just, I'll just lean up against this one and we'll go up and back out your way a little bit. And then I'll use your height and my ladder. And we'll come in here. There we go. Nice. Up there, get the plugs on top. We'll get this edge in. That's the tough one. Not so tough. Okay. All right. And then this guy will go in over here. How are you doing there? And down. Good. Okay. So that's our quick cab. It's loose, but as we start to secure to the rest of the structure, it'll tighten up, and then once we get the Q-fold doors on, it'll even become more secure. So we're gonna add some of the extra screws now, put some in up here, get all the tapes lining up, and we're close to being ready to go. The plug here that you see will plug into the car at the top, and same, we also have another travel cable plug for the auto doors on the top that will go up to the car. We'll run those on up thereafter as well. So yeah, that's the quick cab assembly. All right, so now the quick cab is installed, but it's all loose. All of the screws are loose. The two screws that connect the tubes to the ceiling are still loose, so it can move around and adjust to the alignment of your shaft. So we're going to take a couple of measurements right now just to see how we're lining up with our shaft. And we're a little bit close on this corner, and I'll just see here. And then on this corner, we're pretty close to being bang on, a little bit farther away. And then over on this corner here, we're a little bit closer. We're like three and I'd say just about 3 5/8. So we want to split the difference here. So it looks like this corner has to go back this way, and this one might have to come this way. So what we might do is we'll start with just pushing this wall back a bit, and then as we push the wall back, then we'll just start tightening up the screws on this side, and it should hold it in place. So I'll get my partner to help me with that. Okay, let's try that, and it might come back a little bit after, but we'll give that a shot. So clamp that. Every time I tighten up these bolts here, I'm clamping the structural frame to the panels, and it's adding a bit more rigidity. So we've got the other wall set and tightened. The car's still a little bit shaky, but this wall is tightened. This wall here is the one that's supported by the tube, so once we get that one tightened, it'll make even a bit more of a difference. So now we're going to check just our clearances here. So we've got, at the top here, we've got 3 7/8 there. And over here to the car ceiling, we have about 4 1/16. So we can come over a little bit this way. So what I'll do is we'll just take a little block of wood and we'll pry it over a little bit, and then we'll tighten the two bolts here. What we'll do even first before we do that is that we'll just line up this tube here with this one, because we want the car ceiling and this edge to be lined up, and then we'll give that a little bit of a snug so that it's when we push it over, it stays in place there. Nick, if you want to come and just give a little pressure between, you can use this block too if you want some leverage there on the back side. Okay, a little bit more. Okay, just come a little more in case it springs back. Okay, that's good. And I'm just going to tighten this one up here. That one. Then I'm going to tighten the other side while we're still holding. We're close. Yeah, just under 4 inches. So that's good. We're close to being balanced. So again, we have running clearance on our between our doors and the car, close to 3/4 of an inch. So you don't have to be bang on, but we like to get it as close as possible. So we start off balanced, and if anything else changes or moves, we have that high tolerance to work with. So now we're ready to put on the Q-fold door. So we have the quick cab set up now. It's still a little bit a bit of movement, but until we have the inspection panel wall on here, the car's always got a little bit of movement, but that's to be expected. Everything else has been set up good, so now we're actually ready to put the Q-fold gates on. The Q-fold gate literally mounts to the face of the cab, and there's there's a bolt on every corner. It's a 3/16 bolt with a 5/16 head, and we'll just take those out as we get ready to bring the Q-fold gate in and mount it onto the car. Okay, so we're ready to put the Q-fold gate onto the car. The Q-fold gate comes as one complete package with the gate, the motor operator, the sill, and the mounting channels all pre-wired and mounted and ready to go. So again, we discussed it's going to mount to the car with 4 screws. Got a slot at the bottom, 2 screws at the top, and it's a little bit heavy, but once we get it in and leaning up against the car, it should be stable. So, and there we go. Just keep it close to the header. There we go. Clearing. All right. All right. So it was close to there. So the gate actually has to go above onto the floor. So we'll just lift it and go up. All right. There we go. We're on there. We're on there. That's good. Now all we need to do is we're just going to position it, and we'll use a wooden block, get it up a little bit, and we'll get the bottom slots on. Okay, we'll get the height set a little bit better after. About 1/8 of an inch above the floor. Okay. So the bottom one is slotted and the top one is fixed. Okay, you can let that one go. We'll go do the other side. These upper ones were actually fixed in their height in the factory, so there's no adjustment up here. All the adjustment is down on the slot. So that's solid there, and those are tight, and that one's tight, and let's just see. That should be our Q-fold. There we go. Nice. We're on top of the quick cab, the Stratus, and we want to tie up the electrical cables and plug them into the junction box up here. So we've got the travel cable that came up from the car that we tied up down in the car, and we also have the car control cable. It's got a little plug here, and it will go directly into the junction box. We'll just loosen up this fitting so it can slide up a little bit more along the cable. There we go. And that should tie into there nicely. The travel cable has to go through this clamp right here. And just make a note about when you're on top of the car, keep towards the outside on the Stratus cab when you're doing service on top of it. It's if you're working on it after, there's an emergency stop button here, but don't stand in the center. It's the signs are clear that their panels are not really designed to support a load, but you can stand around the edge of the frame and without risk of damaging anything. So I'll just loosen up this clamp here. Wherever you got a flat cable coming onto a structure, you're always going to see one of these angle clamps on the ram stuff here. So pull it in nice and tight. Okay, so we got that, and we'll take this box cover off because that's where these other 2 cables are going to go into and connect. The other thing you'll see up here is we've got these plugs that are coming out. They're going to plug into your Q-fold. See in here. So we'll probably just push this one back through here. It's nice to keep the connections inside the box, keeps everything clean. This guy's going to go in here. take out the little jumper plug from the shop. And that looks like a nice simple run there. There we go, push that in a little bit more. You can tighten it up, you can move the cable in along the compression fitting there. It just clamps it on. And then this bracket just screws onto the box. Travel cable will come around here into there, and then we'll run the other clamp below there to hold it in place. So C28 plugs into C28. It only goes in one way, like every other Molex plug. Oh, that way. Okay, and C23 is going to plug into C23. Okay, we can fit these back into the box nicely here. Put the cover back on and put the screws back on. So now we're ready to install the controller. So there's a couple components to installing the controller. Number one, we initially had to determine where we wanted to locate it. In this case, it's in a remote location, so the cables are coming over through a duct space in the building and then pulling out through a wall here, and it's actually going to mount back into the controller. All the controller ends of the cables are labeled, numbers on the plugs, and they're going to come in through the back of the box here through these ports. These screws actually are just for shipping. They're screwed in from the inside. We're going to take them out, and then we're going to put the two screws through the plate into the box from the back side. And so all the cables, and we have to think about while we're doing it, they have to flow through and fit in such a way so that they don't interfere with each other. So there's a little bit of planning once we get into that. There's spare ports a lot of the times on the back of the box. They have knockouts on them. There's one with a knockout that's already been made, and that's usually for the electrician to run their main power feed from the disconnects into the box. And there's a few extras in case we need to run any other wires for any other reason, and spares on the box. On the bottom slot here is, this one is where the travel cable comes in. Now, the bracket should be mounted on the box when you receive it. This particular unit has two travel cables, one a bit thicker, so you can flip the bracket around. And really all this does is it's bolted in with a couple of bolts that you attach on the front, and it really just clamps the two travel cables so that they don't pull out. So that's the back side of the box. Now, on this particular unit, we're going to mount the box in an opening in the wall. We're going to bring it back fairly flush, and we're going to be running screws from the inside into the cutout opening, which is about a 1/4 inch bigger than the actual box. It's nice to have a wooden framed opening. There's two different sizes. This is the taller one. There's a shorter one, and you can check your manual and with the manufacturer with us as far as which box is being used for your unit when you're prepping the site. So on the inside of the box, you can see here we've got all the corresponding plugs that are going to hook up to the brackets when they pop through. This wire here is the power that's identified for the electrician to hook up theirs. There's a green for the ground. On this one, there's a white neutral for the 110 that runs the UPS, and of course, all of the elevators have a 220 single phase 20 amp power supply. And again, it doesn't really matter which one goes where. You'll just organize them later. So let's just let's take this one down here at the bottom. And these can all be rotated on the plate as well. So when I'm working with them here, I like to just take my my pliers and loosen up the locking nut. Just makes it a bit easier to work on them so that you can rotate them, rotate the plate, and all these nuts can be tightened up from the inside after once the box is in place. And if you loosen up the nut, as we showed, then you could just rotate the clamp. All right, so we now have all of our techs run in from the back. They're screwed in and secured. We've got to run the travel cable in yet. Notice we ran some techs out this way, some going this way, because we have a big opening, and so this box is going through the wall, so there's no restriction on this side. Otherwise, I'd take more care to run them all in one direction up this side of the box. So to get the travel cable in, we have 2 travel cables. They're going to clamp in the bottom here, so we'll just take off the bolts holding the bracket on. There we go. Okay, so now we're ready to run the travel cables through. Yeah, you'll note that this elevator has 2 travel cables. Typically we only have one, which is the control travel cable. This one has 110 openers on top of the car, so we have another travel cable with 14 gauge wire. So what we want to do is we want to get about, I'll bring this back a little bit here. I'm going to get about a ½ inch or so of insulation. You're going to be clamping the travel cable between the bracket and this tab that's sticking out the back. I'll mention too that if you're doing a single travel cable, you can mount it just like this here, but because this is a double travel cable, we need to flip it around and use the bottom of the slots of the holes because it's a bit thicker in there. So just put this in here. So we're going to put a little bit of tension on the bracket first, just so that when we go to tighten it up on the clamp, it's not flopping around. There we go. Just a little bit tight. There we go. Now our travel cables are in. They don't need to be super tight. They just need to be snug so that secure the cables. As we're moving them back, they're not going to move around and come out. Okay, so we've got all of our cables now secured into the back of the box. We're going to be moving it into the mounting position in the wall, and so that's just usually. It's a 2-man job. You have your partner, and one will flow the cables through, the other will hold the box. In this particular application, we're mounting it right into an opening so that the box will be fully into the wall, and there will only be about a ½ inch sticking past the wall just for the door to close. We also include with every elevator and control system a set of what we call surface mount brackets, and so these brackets can be used if you're going flat up against the wall. You just cut a hole and the cables can go through the wall, and you can use these brackets. They bolt to positions on the top. They have mounting bolts here, and they have screw bolts here for that go into the wall. So, and there's 2 positions that they can be mounted in as well. So this is the surface mount position. You can see the back of the box is flush with the mounting tabs, but there's another hole position on the box where you can move it forward and mount it so it's offset by another 2 inches. And the benefit of that is if you're going into a situation where you're not going directly back through the wall, but all the cables might be coming out the side, you can offset the box mounting position. So we have the box mounted into the wall. It's pushed back approximately about, we've set this one about 3/4 of an inch out from the wall. I like to make sure they're sitting roughly level. Looks like this corner can come up a little bit, but and when we do that, we're going to shim it out. We want to make sure the locking panel is not getting pulled out by the screws, so we can use our our cedar shims to achieve that. Put one down there. And looks like we could probably come up a little bit with this corner here. So I'm just gonna give it a little bit of a lift at the bottom. Let's see if I can get a shim in down here. Something like that. A little bit closer. Level looks pretty good there. Not too bad. We're up tight here now, so that's about as high as we're going to get in that corner. So what I'd like to do also is I'll just make sure that got these shims in here. So I'll just bust these off like so, like that, and I'll just make sure that my door closes okay. We'd like to get probably a couple screws down here. Maybe we'll get one in the upper corner. The side where the drive is more difficult to get at that one. So if we get a couple down here, one here, and one at the bottom corner of the box, we'll be pretty secure. So. Be careful on your wires. Here we go. That looks nice. I'll just do another test on our door. Make sure we're closing nice. And it locks. Good. That's our controller. At any time here we can go and connect all the plugs, and you literally just match up the numbers. C13 to C13, this the motor one, and they only go in one way, so you don't have to worry about mixing the plugs up so that they're not plugged in right. They're fitted in such a way that you won't be able to mix those up. The electrician will come in and we'll hook up the 220. So I'll mention one thing here too is that you see we have a couple of wires here that are labeled auxiliary disconnect. These are two wires for the control that go through an auxiliary contact on your disconnect. So your disconnects will have the main power and then an extra little contact that will disrupt the power to the controls when the main power gets shut off as well. So when it's shipped, it's always shipped where they're hooked together. When your electrician hooks these up, does his connection, he'll run a couple of extra wires through the contact on the disconnect, and it's just a control. Well, we're ready to commission the Stratus. We've hooked up temporary power. We've turned on the UPS control power, so we have power onto our board. We've jumped out the car doors because we need to install this the opposite car door when the lift's located at the top, so we'll move the car without the doors being fully hooked up. We've also jumped out the hall doors until those are installed. So, but we can run the car now and set all the floor positions and also even the door read sensors. So we're going to just go through a bit on the board here right now. So the board is showing run 1, and the first two buttons on the PC board will cycle you through all of the different parameters on the board, tell you different information, and actually allow you to change some of the settings. So run 1 means that all of the safety circuit is intact, and it will run as soon as we push the button. The other thing we have to keep in mind, it's on startup, so first thing it's going to want to do is bring it down. So we'll address that right away. But if we go through the settings, it's set for a 2-stop elevator, FL2. It's set on constant pressure, which is important. There's 3 modes of operation: constant pressure, and then there is automatic, and then auto lowering as well. So for setup and servicing, we want to make sure it's on constant pressure. Next is the floor count. So when you start it up initially, it'll always set it at the top floor count, so it can bring it down and home it to the bottom floor. So no matter where it is, when there's a power outage or the power cycles, it'll always go back to the top floor count to send you to the bottom to home it. So as soon as we put in our lower terminal sensor magnet, it'll change that to 0. SL9, that's measuring the solenoid voltage, and it will detect if there are any errant voltages running to the door locks, and to make sure that the doors only open up when the car's at the landing. T0, that's our run timer set to 0 right now. F1, these are the gate operators, so this one has 2 gates, so the F1 gate is opening at the first floor. F2, we have it opening on the second floor, opens on that side. Go through the gates. It's set for a Euchner lock, different types of locks that you can use on this unit as well, mechanical or victory doors or DF-IO, that's a testing input. Another test input. Error 4, it always shows the last error that the board experienced, and there's a list of errors that each one is described in the PC board manual in your documentation. And the PP is set to 0, so 2 dashes means that the run timer is not activated. And back to run 1, so we're ready to go. Now, before we move it, we're going to go over some of the components on the switches on the guide frame and review what each one of them does. Okay, we're going to go through the switches on the car, and we're going to start with the left side of the car. So if we have a look at the upper section here of the guide frame, and keep in mind all these switches are always located on the guide frame, we have the upper terminal switch. The upper terminal switch, when it sees a magnet at the top floor, it'll tell the car to stop when it reaches the upper floor. And we call it the upper terminal switch because it's not just the second floor; it's the upper terminal floor. So if it's a 3-stop or a 4-stop lift, that will always be the top floor. So it's called referred to as UTS on the drawings, and also there's an indicator light on your board that will light up when the UTS is activated. The one below it in the bracket, at the bottom of the bracket, is called the lower terminal switch, LTS. Similarly, it always signifies when the car is at the bottom landing. When those sensors see the magnet, they actually send a hard count to the PC board, and we'll talk about counting in a second here. But so if it's set for a floor 2 elevator, the bottom one the lower terminal sensor will always be 0 when it sees it. It'll set the count to 0. The upper one for a 2 floor will always be 8 because there's 8 counts between the bottom and the top floor. Another switch on the left-hand side is what we call the upper final switch. This is a physical switch with a positive brake contact. So if the car over travels off the upper sensor, it will hit a bracket that we set at the top landing and remove power from the motor. 2 other sensors on the left side of the guide frame are the door read sensors. And on this unit, there's only 2 floors, so there's only 2 door read sensors. If it was a 3-stop, there would be an additional sensor for the middle stop, and if it's a 4-stop, there would be another sensor for that as well. And they all get mounted on this lower bar underneath the guide frame. So on this one here, you can see the bottom sensor is the floor 1 door read sensor, and the one above it is the floor 2 door read sensor. It's important to note that if this was a 3-stop elevator, the top one would be the floor 3 door read sensor, but in this case we have a 2-stop elevator, so that's your floor 2 door read sensor. When it sees the door read sensors, it will close the contact and allow power to go to unlock the door interlock. And unless it sees a magnet, it will not be able to unlock that door. There's a number of protections built into that circuitry as well. If any one of those the floor read sensors were to weld shut, as soon as you pull out of the landing zone, as we call it, it will send an error and stop the car. Okay, on the right side of the Stratus guide frame, we have what we call the encoder. Similar, all of these sensors exist on the Crystal controls as well. They're all exactly the same, but the encoder and these other sensors are just in different positions between the Stratus and the Crystal. So the encoder is basically what keeps count of the elevator in between floors. So every time it passes the encoder, it'll see 4 pulses. The 2 sensors are quite close together, so it not only determines position but also direction. So as it's passing by a magnet, if it sees the top one then the bottom one, then it knows that it's moving in the up direction, and vice versa. If it's moving down and it sees the bottom one first then the top one, it knows that it's moving in the down direction. And it counts every time it comes onto the magnet and every time it comes off. So it's an important set of sensors that also determine the floor position for mid-landing. So on this elevator, it's only going to be acting as a slowdown and a directional set of switches for this 2-stop elevator. If there was a 3-stop elevator or a 4-stop elevator, there would be other pairs of magnets. At every intermediate floor, there'd be a pair of magnets, and as soon as the encoder goes past the first magnet, either from the bottom or the top, it would stop once it gets in the middle of the 2. So we'll just have a look at where they're located here. So here we are is the encoder magnets. It's a similar bracket as we see over on the left side for the upper terminal switch, but we use the top 2 positions of the holes. There's actually 3 holes in this bracket, and this we call the encoder A, the top one, and encoder B is the bottom one. So the last switch we want to talk about on the guide frame is the lower final limit switch, or some people might refer to it as the nut switch, given that it moves with the movement of the nuts. When the weight comes off the platform, the drive nuts will move down, it'll activate this switch and remove power from the motor. The lower final limit switch, it sits here, and it's activated by the movement of this red bracket. The red bracket is actually attached to the lower backup nut. In addition to being a lower final stop in case the lower terminal sensor fails, it also acts as a sensing switch. If the main drive nut were to fail, then the lower nut would move up, move the bracket, and stop and remove power from the unit. So you on Stratus, similar to Trusty Lift, you have a main drive nut that always carries all the load, and the lower drive nut that just rides without any load for the life of the machine. And as soon as the main drive nut, if it were to fail, the lower drive nut comes up and supports the unit from falling down, and at the same time activating the switch, which will require that the unit be serviced, and it won't allow it to run. So we're ready to start positioning our magnets on the rails. And we always start off, whether it's Crystal or Stratus, with the car at the lower landing, but raised a bit off the floor, a bit higher than it would normally be. So right now, we don't have a pit, but we're still about almost 1.5 inches from the underside of the platform to the floor. We can get closer to that, but we're going to start there, and then we'll move our setting down as we go. So I've located the magnets in the parts box, and they should always be in a plastic bag there, and they just peel off one at a time. So the first thing we're going to do is we're going to position the lower terminal switch magnet, and the magnets on for the lower terminal, or for the upper and lower terminal sensors and the encoder, all just go literally just on the face of this rail. But the lower terminal we need to put underneath, and then move it up. And we're going to watch the board to see where it lights up, because we want to stop it high and then we'll adjust once the car is moving. So I'll put it onto the rail about 3 inches below the lower terminal sensor, just right about there. And now what I'm going to do, I'm going to have a look at the board, and I'm going to move the magnet up until I see LTS light up. So I'm watching. Just nice and slow. There we go. LTS is on. Now I know when I'm coming down, I'm not going to go any farther past that point. Okay, when we're doing the encoder at the lower position, it's pretty simple. We've set LTS, it's lit up, we know that's about where we're going to stop. We're just going to take the encoder magnet and we're going to put it about 4 to 5 inches above the top encoder. We can adjust that position later once the car is moving, but initially what we want to do is we want to make sure that we're well off of the LTS as we go up before it sees the encoder. That's really the key to the encoder counting properly, because the encoder will not count if LTS or UTS are being activated. With the LTS and the lower encoder magnet in place, we're going to run the car up, and then we're going to come back down. But whenever we're doing the floor setting, we want to run the car up past the encoder magnet, so we're going to come up about a good 12 inches, and then we're going to come back down to make sure that the slow speed stages are being activated. Up there, past the encoder magnet, and I'm going to come back down. And you'll notice that the car starts to slow down when it passes the encoder magnet. All right. So you can see it has a bit more run through. We're a little bit lower than we were when we set it. So we're about inch, let's say inch and a quarter. Just a bit under inch and a quarter. We're up a bit on this side. So we're going to bring it down probably about a half an inch. You don't want to get too aggressive on setting the run by in the pit, but you can get very close. So we're gonna try to get within probably a half of an inch between the bottom of the car and the pit. So now that I've done one cycle, when I'm adjusting the terminal sensor magnets or the encoder magnets, I want to make sure that I'm doing it when I'm out of the floor zone. So I'm going to bring the car up past the encoder magnet, and then I'm going to adjust it down. I'll just reach in here. There's my magnet. Bring it down a little bit more than a half an inch, something like that. Okay. And now I'm going to run the car down. Again, I'm not worrying about the encoder magnet. We can adjust that one later, just as long as it's not too close to the lower terminal switch magnet. We're getting pretty nice. 1 inch on the far side and just about 3/4 of an inch on this side. That's getting pretty good. Our overall sill depth is 2.5 to 2 3/4. We can get even lower, but for now, until we're done and setting the ramp, we'll leave that one in that position. So now the other thing that we can do right now too is we can adjust the slow down magnet a bit. So the ideal position for the slow down magnet is that as I'm coming to the floor. Again, this is only at the bottom and the top floors. At the mid floors, the slow down magnets are actually the floor position magnets, so you just set them to stop at the right level. But when we're doing the slow down for the top and bottom floors, you'll listen to the speeds. It'll go through the 3 speeds and then the last one. And we want about a second to 1 to 2 seconds of that slowest speed before it hits the terminal. So right now we have probably about over 2 seconds. So we're going to probably shorten that distance a bit. But again, I'm going to go up, come back down, and then set it that way. So we'll just watch it again here. Okay, and I'll bring it down just a little bit, an inch, and I'm going to come back down. There we go. So went through the 3 speeds, boom, boom, and then about a second before it got to the slowest speed and when it hit the terminal sensor. So we're set at the bottom. The one last thing we want to do is just put a magnet in front of the corresponding floor door reed switch, and this is a very easy one to set. Once you've set your floors, you basically take the magnet and you put it right in front of the RS1 door reed switch magnet. And you just center it about there. As far as the height is concerned, there's really no fine setting to the door reed switch magnet. Once it sees it, it'll send power to the door lock, and the length of the magnets ensure that it won't be unlocking when it's outside of the door zone. Okay, so we've set the lower landing, and again, this is a 2-stop elevator. So all we need to do now is set the upper landing position magnet. So what I'd like to do is I'd like to come close to the landing, but not too close. And I'll just measure roughly. I got about 29.5 inches to go. So what I'll do is I'll take a magnet for the upper terminal switch, and I'll just put it in a little bit lower than 29 inches. I'll probably go about 28 inches to the bottom of the magnet, just to be, again, this is just our first run. We want to stop the car a little bit before the landing, and then we can do an adjustment after that. The other thing we're going to do too is, as we're coming up, is we'll put another magnet on the encoder, so that it does its counting as it comes up into it. So if I put that one at 29 inches, I'm going to put the encoder one at 23 inches, about 6 inches lower, just so it fully passes the encoder magnet right about there. Okay. And now we'll give it a shot and see how that goes. There we go. Still pretty close to the encoder there. There wasn't much of a slowdown speed, so. But I got about 1.25 inches to the landing. Measure on both sides. Yeah, about 1.25 inches. So it's pretty simple. We're going to bring it down again. We won't move the magnets while we're on them, but we're going to bring it down, and I'm going to move the upper terminal magnet up about 1.25 inches. Upper ones are always easier because you can work from below. And I just bring my measuring tape and just move her up there. I'm going to leave the encoder magnet in its position because there wasn't a lot of time between the last slowdown and when I got onto the terminal. So increase that distance a little bit would be a good idea. So we'll come back up. There we go, nice, and it feels pretty good. Notice that there's going to be, when the flooring gets finished, there'll be a little bit of carpet here, so See, it's very easy to adjust the floor levels. We can leave it at that for now, and we can do a final adjustment when the flooring and everything else gets finished. So the last one to do here, again, very, very simple, is just to put in the door reed sensor magnet, and that one, like the lower one, not very complicated. It simply just goes in the middle of the upper switch. So again, that's the lower door reed switch. That's the upper floor door reed switch. I'm just going to put it onto that angle, face of the angle, right on the face. I want to point out one thing too, is that you notice that a lot of all the magnets are going off to the side of the reed sensor. When some people look at the reed sensor, they think, well, maybe the magnet should be right in front. Actually, if the magnet is directly in front of the reed sensor, the magnetic fields will balance each other out, and you can actually have a dead zone. So the ideal position is always the reed sensor is on the side of the magnet, and that's when it senses best. So that's why all of our magnets run on the side of the sensor. So that's setting the floor limits and the door sensors, and we're ready to go. So our Stratus is installed. We've got it going up and down. Everything is operational. We've set our limits, the lower limits, the upper limits. We like where it's or how it's functioning. And at the end of the installation, what we'd like to do is a couple of tests. The first test we're going to do is full load test. So simply what we do is we'll load the car with full load, which the Stratus is an 800-pound capacity unit, so we're going to put 800 pounds into the unit, and we're going to bring it all the way up, and we're going to check that it's stopping nice and level at the landings, and then we're going to bring it all the way down, and we're going to check that it's stopping well at the bottom. That'll be our first test. The second test is what we call a braking test, and a braking test is a requirement that the elevator is capable of braking not just the full load, but 125% of the load. So we're going to put 125% of the rated load on, start from the top, go down, stop a couple times, and then bring it all the way down to the bottom and see that it stops in a nice controlled manner at the same level that it did with capacity load or empty load. So we'll load up our car now with our test weight. Okay, so we have our capacity load in here, which is 800 pounds. I've thrown in an extra 50 pounds to account for the inspection panel not being installed. So we'll run it up to the top and see if it stops at the landing level that we set previously. Nice. There we are. Flush with the landing. Handle the load okay. Now we'll take it down and we'll check the stopping at the bottom. There we go. So nice controlled stop at the bottom. At the top, it's bringing it up nice and level with the landing. So that's our full load capacity test. So now next thing we're going to do is the 125% load braking test. Okay, so we have our capacity load in here right now, and we're going to put another 25%, so 200 pounds, because the capacity is 800 pounds, so 1.25 times 800 is 1,000 pounds, so we want to put 1,000 pounds into the unit. And again, the overloading situation is not, it's actually not to prove that the lift is going to lift 125% of the load. It just wants to protect the lift from moving down when 125% of the load gets in. So the braking test is literally just in the down direction with the full load. So we'll go down and we'll see how it stops at the bottom here. And there we go. Nice controlled stop. You notice it actually even went a little bit lower with 125% load, but it still kept it up just a little bit from the ground. But what we're mostly concerned about is that the motor, the drive, all of the components that will stop the lift is capable of handling that overload situation, which this one did.